In today's class of polynomials, we will be discussing about the remainder theorem and the factor theorem. Now, so far, what have we studied in polynomials? We have studied about the value of a polynomial, any polynomial px at any given value of x. So, from that we have identified or we have learned how to identify the zeros or the roots of a polynomial. Whichever value of the polynomial give you a zero, that particular value of x is called as the zero of the polynomial. Now, after that, we have learned how to find out the root of a linear polynomial. Suppose a linear polynomial is given to you. You are asked to find out the zero of the linear polynomial. We have to equate the linear polynomial to a zero and find the corresponding value of x. Okay. Now, the next part that we move on is the remainder theorem. Now, the remainder theorem brings us to the division of a polynomial by another polynomial. Okay. You know about the concept of remainder, which you know about the concept of a quotient as well. You also know that dividend is equal to divisor into quotient plus remainder. That is basic of division. Okay. You have 18 by 3 will give you a 6. I know 6 is a quotient and my remainder is a 0. When we are checking it, dividend is equal to divisor into quotient plus remainder. So I get back 18. So which is the actually my original dividend. So I know that this particular statement holds true for numbers. So if I have 18 by 4, what would be my quotient? My quotient would be 4 and my remainder would be 2. Again, if I am checking this particular statement, my dividend would be divisor into quotient plus remainder 16 plus 2, 18. So again, I get back the original number. So whether I have a remainder as 0 or whether I have a remainder as some other number, I know that dividend will always be equal to divisor into quotient plus remainder. Now let us move on to polynomial division. Okay. Let us take any random polynomial p of x. Okay, p of x, let us say it is equal to 3x square plus x. Let us take any polynomial px, 3x square plus x. I am asking you to divide this polynomial by another polynomial which is qx, which is x. So what is x? Here I have the divisor that I have taken. So I know that this is my dividend and this is my divisor. The divisor that I have taken here is the simplest divisor, which is a monomial. So, if you can recollect, monomial is a polynomial having only a single term. It's a single term polynomial. So, here I have taken only x and it is a linear monomial. So, when I am telling you it's a linear monomial, so what is a quadratic monomial? A quadratic monomial would be x square. Cubic monomial would be x cube, etc. Okay. Now, whenever I am dividing a polynomial here, I have taken 3x square plus x by a monomial x. I have to, this is what they are basically asking you to do. Divide each term by the monomial. So, you have learned about exponents, you have learned about exponential division also. So, here I will get 3x plus 1. And there is no remainder. Okay. Every term is divisible by the divisor. So, I can safely say this is my quotient and my remainder is a 0. Okay. Let us check my original statement. Is my dividend equal to divisor into quotient plus remainder? So, I will get dividend. Let us see what the dividend is. Divisor into quotient plus remainder. So, I will get 3x square plus x, which is my original dividend. So, in this particular sum, we have seen that it holds good when the remainder is a 0. Let us take a condition when the remainder is not a 0 for the polynomial here. x square plus x plus 1. So, when I am dividing, what is it that you are doing? This. Each term 3x plus 1 plus 1 by x. So, I can see that this 1 by x it is not a proper division. It comes not as a polynomial. So I will get 3x plus 1 as my quotient, and this particular one standing over here will be my remainder. The part of the polynomial that is not divisible by the monomial is my remainder. Okay. So let us see whether the original statement works. My dividend should be equal to divisor into quotient plus my remainder. Okay. This is my divisor into quotient plus remainder, which is equal to the original dividend. Okay. So we have just attempted the simplest form of a polynomial division by a monomial, and we have verified if dividend is always equal to divisor into quotient plus remainder. In two sums at least, you can see that it is valid. Okay, now let us take another polynomial. Let us say px itself. 5x cube plus 9x plus 7. Okay. And I am taking my divisor as x square. Now again I have a monomial as a divisor, but again I can see that it is not a linear divisor, it is a quadratic divisor. Method is the same. Each term has to be divided by x square. What do we get? The first term easily is divisible. I can say it is 5x plus 9x plus 7 by x square. You can see that it is not properly divisible by x square. Okay. So I can say that in this particular polynomial, when it gets divided by x square, 9x plus 7 is my remainder. Whichever part of the polynomial is not divisible properly by the divisor is my remainder. Okay. So my dividend has to be equal to divisor into quotient plus remainder. Let me see. What is divisor? What is the quotient? Plus, what is my remainder? This is my original dividend. Okay. So, if you are given a polynomial and you have a monomial divisor and they are asking you to find the quotient and I have to find the remainder, divide each term of the polynomial by the divisor. Wherever perfect division is possible, that part would be your quotient. The remaining part, which is not properly divisible by the given divisor, is your remainder always. Okay. If you want to do one more sum, it is 7x raised to 4 plus 9x raised to 3 plus 7x plus 15. I have to let my divisor be x raised to 3. What do you get? 7x plus 9. This and this term both are properly divisible. So this will be my quotient plus 7x plus 15 is not properly divisible by x raised to 3 and this would be my remainder. Okay. So let us check again. Divisor into quotient plus remainder. Okay. Now let us move on to the next part. The division of a polynomial by a binomial. Okay. Polynomial 3x square plus x plus 1 and okay, right now I will start with a binomial which is a linear binomial, which is the simplest one, x plus 3. In order to do this, if you have to divide and find the quotient, we have to do the long division method. So first let us see what the long division method is and how it is related to the remainder theorem. Okay. Now 3x square plus x plus 1. My dividend is, my divisor is, let us say x plus 3. Okay. Now the first step before proceeding with the long division is, arrange the dividend and the divisor in terms of decreasing degree. So sometimes your dividend can be given as x plus 1 plus 3x square. Basically the terms could be jumbled up. If the terms are jumbled up, it is your job to arrange it in a proper decreasing degree order. So arrange it as 3x square plus x plus 1. Similarly, the case with divisor also, they could give you the divisor as suppose minus 2 plus x is your divisor. It is your job to arrange it as an x minus 2. Okay. Now, my dividend goes here. My divisor goes here. Okay. My quotient appears here. My remainder will come after my calculations are done, if there is a remainder. Okay. Now, identify the first term of the dividend and the first term of the divisor. So, my first term of the dividend is 3x square. First term of the divisor is an x. So, divide the first term of the dividend by the first term of the divisor. What do I get? I will get a 3x. This is my first term of the quotient. Okay. Once you have identified the first term of the quotient, multiply that first term with the complete divisor. So, I will get 3x square plus 9x. Okay. The next step. Subtract line 1 minus line 2. It is always line 1 minus line 2. 3x square minus 3x square is 0x square. X minus 9x is a minus 8x. And bring down the rest of my dividend over here. Okay, 1 minus 0 is a 1. Okay. Now, this is my new dividend. This was my original dividend. This is my new dividend now. Identify the first term of the dividend, minus 8x. My divisor is the same. It is not changing anyways. First term of the divisor is x. What do I get? I get a minus 8. I'll put it next to the quotient. Okay. Then I proceed as in the previous step. That particular number that we have identified now, I will multiply with the entire divisor. So minus 8 into x plus 3. I will get minus 8x minus 24. What is my next step? Line 1 minus line 2. 1 minus minus 24 will give me 25. Now, further division is not possible. Why is further division not possible? See, when you are trying to, this is my new dividend now, correct? When I am trying to find out 25, this is the first term of my dividend. Identify the first term of my divisor, which is x. 25 by x ceases to be a polynomial. Okay. I have to stop the division at a point where the degree of my new dividend becomes less than that of the divisor. Here, the degree of my new dividend is 25x raised to 0. It is a 0 degree. Here, the degree of my dividend is a divisor is a 1. So, I have to stop my division here. So, what is my quotient? 3x minus 8 is my quotient and 25 is my remainder. Okay. Now, let us check whether dividend is equal to divisor into quotient plus remainder. What is divisor? What is my quotient? Plus remainder. Open the bracket. 3x square minus 8x plus 9x minus 24 plus 24. So, what do I get? 3x square plus x plus 1. This is my original dividend. Okay. So, when you are doing the long division method, my first step would be to rearrange the terms according to decreasing degree for the dividend and the divisor. Okay. My quotient will appear on the top. This is my dividend and this is my divisor. Identify the first term of the dividend and the first term of the divisor. Divide them. You get an answer here. That would be the first term of the quotient. After that, multiply all the terms of the divisor with the quotient. Subtract line 1 minus line 2. I get a new dividend. Repeat. Identify the first term of the dividend and the first term of the divisor. Divide. Write down the number here. or the term here. Multiply that particular term with the entire divisor. Subtract. This is my new dividend. Check the first term of the dividend, 25. Check the first term of the divisor, x. I can see that no further division is possible. I stop. This is my remainder and this is my quotient. Okay. Let us do one more sum. Now this time let us use a complicated divisor, a slightly more complicated divisor. Let us use a quadratic divisor and then or we'll use a trinomial also. Okay. Okay, now I have written a slightly more complicated dividend and slightly more complicated divisor here. My divisor is a binomial and it's a quadratic binomial. Okay. So what is my first step? I have to rearrange the terms of the dividend as well as the divisor in terms of decreasing degree. So 7, 5, 2, 0. I am talking about the degree 2 and 0. Okay. Now identify the first term of the dividend and the first term of the divisor. Minus 8x raised to 7. What do you get? 4x raised to 4. Write it down here. Multiply 4x raised to 5 with the complete divisor. Now, line 1 minus line 2. 6x square minus 0x square. Minus 1 minus 0. Okay. So, here comes my new dividend. What is the first term of the dividend? 5x raised to 5. First term of the divisor. What do you get? I will get a minus 5 by 2 x raised to 3. Okay. If you get a fraction here, you don't have to worry about it because it is a very normal thing that you will not get a perfect whole number over there. So, whatever be the answer that you are getting over here when you divide the first term of the dividend by the divisor, just write it down there. So, you will get minus 5 by 2 x raised to 3. What's my next step? I have to multiply the entire divisor with minus 5 by 2 x raised to 3. So, what do I get? So, minus 5 by 2 x raised to 3 will give me, okay, agreed? What's my next step? Line 1 minus line 2. This and this becomes a 0 x raised to 5. The next term of my dividend is 6x square. I can see that there is no x square term here. 6x square minus 0x square will give me 6x square. Minus 1 minus 0 will give me minus 1. But I can see that I have left a term in the second line over here, which is an x cube term. There was no x cube term in the previous line. That was a 0x cube. So I cannot neglect this term just like that. So I have to sub 0x cube minus 5 by 2 x cube will give me plus 5 by 2 x cube. Is that clear? In case there is no x cube term, in this case there is no x cube term over here, but then I can't completely ignore the term over here because it is line 1 minus line 2 will always, I have to take into account every single term. So, because there is no x cube over here, I will write it as 0x cube, right? It should have come here. So, 0x cube minus 5 by 2 x cube will give you plus 5 by 2 x cube. This is my new dividend. What is the first term of the dividend? 5 by 2 x cube. What is the first term of the divisor? Minus 2x square. Oh my god, I couldn't take something more complicated. Okay, so x cube minus x square, x cube by x square is x. Minus 5 by 2 by minus 2 will give me minus 5 by 4. So it has to go here. Multiply the entire divisor with minus 5 by 4x. What do I get? I will get plus minus minus 5 by 4x into 1 is minus 5 by 4x. Subtract. This and this will get cancelled. 6x square minus 0x square. Minus 1 minus 0. I have a minus 5 by 4x. There was a 0x here. 0x minus 5 by 4x will give me plus 5 by 4x. Agree? Now, I can see that this is not in decreasing degree. So, I will just rearrange it as 6x square plus 5 by 4x minus 1. Okay. The first term of the dividend is 6x square. First term of my divisor is minus 2x square. What do I get? Minus 3. Multiply the entire divisor with a minus 3. What do I get? Okay. The first term, it will get cancelled. 5 by 4x minus 0x will give me 5 by 4x. Minus 1 minus 0 will give me a minus 1. Oh, sorry, there is a 3. Minus 1 minus minus 3 will give me a plus 2. First term of the dividend, 5 by 4x. First term of the divisor, minus 2x square. I can see that the degree of the remainder is less than that of the divisor, or degree of the new dividend is less than that of the divisor. So, I stop my division. Thank God. Okay. Now, this is my quotient and this is my remainder. Okay. Now, we have to see if the dividend is equal to divisor into quotient plus remainder. Okay. Fine. Dividend, divisor, quotient, remainder. Very complicated quotient. Okay, fine, whatever. So, quotient into divisor plus remainder is what we have to check, right? Quotient okay guys, so I have done multiplication of two polynomials plus remainder. I have opened the bracket and I have expanded the terms, and this is what you get. I have actually spared you the torture of me writing down each term. So you can see the terms over here, and when you add it up, you are getting the original dividend. Now the thing is that you can take up any polynomial that you want to, any random polynomial, divide it by any another random polynomial and find the quotient and remainder. In order to see if you are right or not, just use dividend is equal to divisor into quotient plus remainder and see if your answer is correct or not. See, the thing with the long division is that it is a lengthy process. Yes, it is lengthy, and as and when the dividend and the divisor gets more complicated, it becomes also more lengthy. No, the thing with the fact is that, see, just because you don't like a particular chapter or you don't like a particular topic in maths, and maths is not a subject that many people like. Most of my students say that we are forced to study maths. I always feel that they do not like maths because they are not able to solve the sums that are given to them in a class or given to them, when they are writing a test. And I always feel it is because of lack of practice. As a teacher and as a student who has always struggled with maths, I always feel that, when you are getting the chance to improve yourself in maths, please do so. When you are presented with an opportunity as to excel in long division, not many students do excel in long division, I would suggest that you take up any polynomial and a divisor and practice. And if you don't want to do 5 sums in a day, that is absolutely fine. Do 1 sum in a day, but be consistent with that 1 sum every single day. Because your improvement will come only over a period of time. It will not come overnight. Unless you are exceptionally good in maths, it will not happen overnight. So any part of the maths that you do not like, any part of the maths that you hate, that is absolutely fine. You don't have to actually like the subject to excel in it. You just have to practice maths. Okay. Now, in this case, it was a very lengthy division actually with fractions and everything involved. And even I was not even sure that I would get the correct question, but yeah, thankfully I have got it. Now we will move on to the remainder theorem and see why remainder theorem is more preferred when you actually have to find the remainder when you are dividing a polynomial by another polynomial. Okay, fine. Okay, now remainder theorem. Now what does remainder theorem state? It states that when a polynomial qx, which is of a degree greater than or equal to 1, is divided by x minus a, the remainder is p of a. So I have a polynomial px, any degree greater than 1. Okay, if it is divided by x minus a, so which means x minus a is my divisor. It is a linear divisor. So we are talking about the remainder theorem when we are dealing with a linear divisor, not a quadratic divisor or a higher degree divisor. See, there is, of course, the remainder theorem is applicable for a quadratic divisor or a cubic divisor also, but it is slightly more complicated. But we always say the remainder theorem as concerned with a linear divisor. So px is divided by a linear divisor x minus a. My remainder will be p of a. So what they are telling is that don't go through all this long division in order to find the remainder. Just substitute a in the place of x in order to find the remainder. Let us see if this is true or not. Okay. In this particular sum, this is my dividend. This is my divisor. Okay. In this case, I cannot apply because the reason being it is a quadratic divisor. So let us take the previous sum in which we had a linear divisor and see if this holds true. Okay. Okay. This was the previous sum. 3x square plus x plus 1 and x plus 3. And my remainder I remember was 25. Right? Now they say that p of x is divided by x minus a. So what is x minus a here? It is, what is the value of a? If I am dividing, they say that my remainder will be p of a. They are basically asking you to find the value of this polynomial when x is equal to minus 3. I have gotten back the original remainder that I got when I did long division. See, this is the reason why when a question is asked for the students, find the remainder when a polynomial so and so is divided by this polynomial, they immediately do the remainder theorem, because you can see that it just gets over in one line, whereas the long division is like, so lengthy. This will help you in finding the remainder, but then it will not help you in finding the quotient. Okay. So the remainder theorem, once again, it is when a polynomial px of a degree greater than or equal to 1 is divided by another polynomial x minus a, or a linear polynomial x minus a, the remainder will be p of a. So I have written it again. When p of x is divided by x minus a, my remainder is p of a. So let us see how this works. Yeah, there is a proof that is given in the NCERT textbooks, and yes, you have to go through it. Okay. Now we know that the dividend is equal to divisor let us say it d of x, divisor into quotient plus remainder, right? When we are talking about the remainder theorem, what do you know about the divisor? The divisor is a linear divisor. It is x minus a. Fine. You also know that when you are doing long division, when do you stop the long division? You stop the long division when the remainder, the degree of the remainder is lesser than that of the divisor. Okay. If you have a quadratic divisor and your remainder is a linear one, you stop it. If you have a linear divisor and your remainder is a number, you have to stop it. So in this case, in the remainder theorem, we are speaking about a linear divisor. So my remainder has to be a number. Okay. So because it is just a number and there will not be any x term as such involved in it, I can write it as an r. Instead of writing as an r of x, I will write it as an r because it is a number anyways. Okay. Now it says that, so this is my remainder. Okay. What is my divisor? Divisor is always x minus a when I am talking about the remainder theorem here. Quotient, let it be anything. Okay. Now, what does it say? It says that the remainder, when the polynomial px is divided by x minus a, the remainder has to be p of a. So, polynomial px is divided by x minus a, the remainder has to be p of a. What do you mean by p of a? Wherever x is there, I have to put a over there. So, where do I find a here? So, my p of a would be a minus a, which is a 0, into q of x plus r. This becomes a 0 plus r, which is r. I get by the remainder. Are you guys okay with the proof?